I want all of you guys to keep tweeting about this conference. You know, we have had more than 200 tweets in the last 3 hours now. So I want all of you guys to please keep on tweeting with the hashtag DOIS19. Please remember that hashtag DOIS19. It's not DOIS 2019 or DevOps India Summit. It is DOIS19. So please keep tweeting about the conference, about the speakers, what your takeaways, what you have learned from the sessions, what you would like to see in the next sessions or in the next conference, in the next year's leg. But we want all of you to please keep on tweeting. And because, you know why? Because we have 2 amazing prizes to give away, right? The topmost tweet goes home with the Kindle Paperwhite 10th generation, and the second winner goes home with the Eco Dot 5. All right, ladies and gentlemen, let's move on to the next session. All right, some of you have been asking about the agenda and you've been really confused. So all of you have had the hard copy of the agenda with you, so please refer that. And other than that, we have the LED screens in front of every hall. So please refer to the LED screens if you want to see which track has which speakers on what topics. If you want to refer that, you can do that on the LED screens as well as the hard copy of the agenda that you have received in your welcome kit. All right, thank you, Mark, for your time. It's my privilege to introduce our next speaker for the day to all of you. He is a cloud and a software architect, entrepreneur, and tech author, and is founder of Era Labs, a company that provides training and knowledge to individuals and businesses to help them accelerate the DevOps learning, enable innovation, and build modern and cloud-native applications. He is the curator of DevOps Links community, a great resource for DevOps content. And today at the DevOps India Summit, he is here to give us an insight on the best practices for designing cloud-native application. Joining us now, all the way from Paris, France, please put your hands together for none other than Mr. Ayman El Amri.
So thank you for coming. Today I'm going to talk about cloud native, and more specifically about the best practices to design cloud native applications. So there are 2 types of applications today. Applications that are cloud native, or systems that are cloud native, and systems and platforms that are not cloud native. And today, we're going to talk about the first types of applications. So let's be clear about one thing before we start, which is the term cloud in the term cloud native. So cloud for me is not just AWS or GCP. It's a philosophy. It's something that it's a way of developing software. It's a way of delivering software. It's not just a cloud provider. It's not a place, and like the founder of Dell, for example, said, the cloud isn't a place, it's a way of doing IT. I agree with this. And to understand cloud native in simple words, think about it as an evolved form of software, of the old norms, of the old monolithic software and applications. So for example, if we take a look at this picture, we can see that this bird, or these 4 types of the same bird species, there is the 4th type which have a longer beak, and it can extract food from narrow openings. This doesn't mean that the first type of birds will disappear, but it means that it will disappear faster than the 4th one. And this is an analogy to the comparison between cloud native and monolithic software. So monolithic software will never die like this because just of the cloud native software, but it will continue to support the ecosystem of IT, and it will probably disappear faster than the cloud native. And during this evolution journey of the software engineering, we have seen many methodologies and philosophies, like, for example, and implementations, actually, like the successful Netflix implementation of DevOps, like the 12-factor app, like the 13th-factor app, and other methodologies, actually. And what I've been doing before this presentation is that I try to extract and look into the most common and the most important design principles and design patterns from all of this methodology, and also from my experience and the experience of other people. And I tried to summarize all of this and extract some design patterns, and then move to the best practices to implement these design practices, these design principles, or patterns, sorry. And I found that we can categorize them in three main categories, which we call the golden triangle. So the first thing is people, then processes and technologies. And people are the most important part of this triangle. Then comes the processes, and finally comes the technologies. And one of the pitfalls or mistakes that we can see in some companies is that we try to adapt people to technologies. And we should like adapt technologies more to people, not the contrary. So I finished it up by having 15 design patterns, and I will talk about each one of them. Then we will move to the practices to implement all of these design principles. So the first thing that I found is that products over projects, or products are more important than projects, because the mental model or the upfront thinking of the project's delays, the project costs, etc., is something that is not working anymore. And if you, one of the challenges that in the agile methodology in DevOps also is the continuous discovery and the continuous improvement. This replaces actually the old mental model of a project. The second thing that I found is features over releases. And it looks actually like the first one, but it opens also the gate to other creative ways of thinking, and especially from the human side and from the organization side, which is, for example, methodology or implementations like the feature teams or the two-pizza team. The third thing is reusability. The fourth is technology agnosticism. And we can see technology agnosticism, for example, in teams or large teams that are composed of smaller teams, and each team is free to implement and use the technologies that they would like to use or they need to use without worrying about the whole picture or the whole landscape of the ecosystem. So this will increase the productivity and the autonomy of each team and each developer. Then the portability. I think everyone knows what is portability. The abstraction, and we're going actually to see all of this in details later. So we have also cost. It's an evidence, speed, and scalability, but from a business view. I know that we have scalability from a technical point of view, but to make the difference between them, scalability from a technical point of view is not a design principle. It can be, but it's actually more, it's a goal. It's not, sorry, it's a tool. It's not a goal, but business scalability is a tool. So what I mean by business scalability is that when we have a software, we can add new features to this software without impacting the old features. And if we want to modify or adapt the old features to new business domains, then we will not need much a major rework for the whole system. This is the business scalability. Then the self-service and the elasticity. And to understand elasticity, let's take two simple examples, because elasticity can be categorized into two categories: the time-based elasticity and the value-based elasticity. So for the time-based, imagine it's a very simple example, but a developer can shut down a machine or an instance, a cloud instance, when he or she didn't use it, or when the machine is not used anymore. So this is the time-based elasticity. And value-based is the technical scalability, where we can, for example, add CPU or add more instances or more physical resource to the machine in order to support more workloads. Then come the resiliency, which is, like, we say that the system is resilient when it stays responsive in face of failure, and especially when we have, for example, a change in the the production system, like, for example, more traffic or less traffic, then it will adapt itself to these conditions. Then we have security, because security should be implemented from a design point of view. It should not be added as a layer to a finished project. It should be within all the layers of a project. Then comes the observability, and by observability is a feature actually that makes a system monitorable. And finally comes the simplicity, which is very important and very difficult. So since we implemented, or we want to implement all of these design principles, so things may become complex in the system, but they should not become complicated. So these are the 15 design principles that I extracted from all of the methodologies we have seen, and my experience, and I saw also other people's experience, and I tried to answer the question, the why. So I started with the why, and now I'm moving to the how. And by how, we mean the practices or the best practices. I prefer saying good practices because best practices means that I am on the top and that I will never reach any other level on top of my top, actually. So good practices is a good term to employ in this case. So in order to see what are the best practices that I need to implement those design principles, I created a two-dimensional table where in the rows I added the patterns we have seen, and then I tried to add and to imagine what are the practices that I need to implement all of these principles and design patterns. And this is what I found. I found that the first and the most important thing is that you should design for culture. And by saying you should design by culture is focusing on the human side and the culture and the organization side of teams. So for example, being knowledgeable about the Conway law means that you can organize your team in a way that will be linked or affect the technical architecture of your software. The second thing that I found is that we should design for composability. And by composability here, I mean that, for example, one of the examples is designing microservices. So microservices are just one example of this best practice or this good practice designed for composability. It's not the goal, it's a tool. Probably one day we will have other systems that are better than microservices and we'll move to them. But composability is important because it has very positive aspects, like, for example, building polyglot microservices. And when we build polyglot microservices, we can reach the independence of teams. Each team can use its own its preferred or the technologies that they need to implement in order to achieve their goals. And by composability also, we can use other technologies, for example, like Docker, containers, or serverless like Lambda, for example. The third thing that I found is designing for automation. And automation is really important because it allows us also to have the abstraction later. And one of the things that we should know before thinking about automation is that we should simplify and secure before automating. The fourth thing that I found is designing for statelessness. And we can think of statelessness as, a smarter type of applications. So monolithic applications are not stateless, they are stateful. And stateless applications are smarter because they allow us to implement technical approaches like scaling up and scaling down easier, like, for example, the graceful termination of services, like the zero downtime rollbacks, and like load balancing, for example. The fifth thing that I found is design for dev prod parity, and this is the same thing that I can find also in the 12-factor app. And having a parity in the development and production environments, and also other environments like testing and staging also, has many benefits because we can, for example, make tasks like CI/CD much easier. Number 6, design for isolation. And when you design for isolation, you will use technologies like containers, or for example, other alternatives of containers like micro VMs, for example. Then design for interaction and collaboration. Remember the Kanawai law? And when you design for interaction and collaboration, it means that technically that you should, yeah, in a microservices context, design applications that will communicate with each others that are independent, but communicates using APIs or lightweight APIs. Number 9, I found that abstraction is really important, so design for abstraction. And to understand abstraction, let's look at how Kubernetes is creating this abstraction, actually. So if we look at Kubernetes on the past, it didn't exist. There are bare metal and some cloud providers. But let's take the examples of networking, which is virtualized at the moment. So VNF is the virtualized networking functions. It's virtualized networking functions, for those who don't know about it. It's network physical, but it's in a virtualized form, like machines, like virtual machines, for example. And in the future, Kubernetes can have the total abstraction of any cloud and bare metal, also any type of hybrid cloud and multi-cloud. And you can run it on top of any infrastructure in order to run also the CNFs, which are the functions, but not virtualized, but containerized. So thanks to containers, because now we can run almost everything within containers, and then we can run them on top of Kubernetes. So we'll have even the function networks will be containerized. So this is what I mean by abstraction, and this is what Kubernetes can help in making more abstraction in the whole ecosystem of IT. So number 10, I found that it's very important also, design for business. And by designing for business, you can create business capability teams and deploy business services. Then I found that designing for immutability is also something that we need to have in order to have some of the design principles that I quoted in the beginning. And by immutability, I will take a simple example for those who don't know about immutability. So in the past, when we deploy software, we SSH into our servers, and then we deploy the software from Git or from any artifact, for example, or any other source. And this is the old way of deploying software. And by immutability, we mean that the old server should be disconnected from our production. And we should build a new server with a new image, and it will be provisioned with the new image or the new version of our application. Number 12, I found that designing for observability is really important because observability is the new type of, or the new monitoring. And to understand observability, let's look at two things. And let's compare what we call black box and white box monitoring. So there are two types of monitoring. In the black box monitoring, it's the old way of monitoring system. It's passive. It will describe the symptoms. It will, it's descriptive, and it don't need any change in your code base. However, if we look at the white box monitoring, you should change your code to add some code in order to ensure that this type of observability or monitoring is there. Then if you compare it to the black box, it's active, and it will tell you the causes, not the symptoms. And in white box monitoring, we focus on metrics, logs, and tracing. So it's something that we can implement in order to have a predictive system. And by saying predictive, we can also imagine that we can also employ machine learning, for example, in order to parse the logs or read the metrics and read the tracing and make some predictions. So our systems can be more smarter by white box monitoring, and that's why observability is really important. Then number 13, I find that security, it's obvious that security is important, but in many companies, security is not really prioritized, and it should not be prioritized. It should be designed within the system like any other feature. So it should be a kind of feature. Security should be, systems should be secure by design. Then design for simplicity, and simplicity can be complex. But there is something that can inspire all of us when we design software. It's the Unix approach and Linux system that are based on, of course, Unix. So Unix philosophy, if we read, for example, 3 of the principles of Unix, write programs that do one thing and do it well. This reminds us of the microservices architecture. Write programs that work together. This is also microservices. And write programs to handle text streams because it's a universal interface. This also reminds us of how microservices communicate with each other in order to reach business goals. So Unix is really a source of inspiration for development software engineering. It will stay something that inspires all of us. And one of the, this is my favorite because designing like nature, because nature on its CV has 13 billion years of experience in research and development. So I don't think that we can be smarter than nature. And, dinosaurs, for example, that are weighty and slow creatures, have disappeared and left the Earth for smaller and more agile and smarter species. And we can see this actually in software engineering. However, I don't think that monolith applications will disappear, but they will continue to support the IT ecosystem for years. And the fact that microservices, for example, are more sophisticated doesn't mean that the monolithic software will disappear from one day to another. So compare monolithic software to this whale. And when a whale dies, it will support a community of living organisms for more than 50 years. The second thing we can learn from nature, though I call it the afterward optimization. I don't know if it exists really, but this is what I called it. And by afterward optimizations, I mean that if we look at nature, we will notice that nature has, nature creates first, then optimize later. And this is what we can do actually. When I'm not an expert in this, but when we have some genes or a genotype that is transmitted from one generation to another, sometimes there is a mistake or mutations. Sometimes there are these kind of mistakes. And when this mistake become a good phenotype or something that is helpful in everyday life for this creature or for the second generation, then nature will conserve it, will keep it. So this is not really a mistake, it's an experiment. It's like nature is having many experiments. It's maximizing the number of experiments in order to learn and find the best thing to keep. So continuous experimentation is something that we learn from nature. The afterward optimization is something also that we can learn from nature. So build, then optimize. And if we look also at the Unix philosophy, if you Google the philosophy of worse is better, you can understand also that this is also some kind of do first, then optimize later. In order to implement this, like from nature, for example, you can learn to optimize later. In order to implement this, we can see what is, for example, the monolith first approach. So I know that microservices can be hard. For example, cloud native can be, frustrating if we have a technical stack that is monolithic and cannot adapt to new changes and, So by having the monolith first approach, you can consider microservices as something, or cloud native as something you can evolve into, not something you can start with. So this presentation is, I just finished the presentation. Thank you for coming. You can join my community fund.dev, and if you have any questions, yeah, please.
All right, thank you, Eamon, for that wonderful session. Let's have a bigger round of applause, everyone. Come on. Okay, we are a little short of time, so what we're going to do is, if you have any questions for Eamon, you can please connect with him in the lunch and the networking break. Right now, we cannot take any questions because we're a little short of time. But what we'll do quickly is, I would request you to ask 2 questions to the audience today, based on your session, and we're going to give out some prizes to them. So quickly, a question from your session that comes into your mind.
From the presentation?
Yes.
Okay. How can, what is the abstraction, or where can we see the abstraction, or how can we see it in Kubernetes, for example?
All right.
Yeah.
We have, you want us to say? Yeah. Okay, I think she raised her hand first. Yeah. Can we give the mic to her?
Abstraction is something where you don't want to show anything. So Kubernetes is something on top of it. You can scale up and down where without showing anything. So that's how it is.
All right. Any more answers? You want to take some more answers?
Yeah.
All right. Can we have the mic to the person with black t-shirt? Yeah.
Yeah, could you please repeat the question again?
He's asking you to repeat the question.
This is the afterward optimization. So he starts first, then he optimizes later. How can we see the abstraction in Kubernetes? How can we see it actually in the schema that I described it later?
So I believe it's the adaptability. So if you see on the first page, there was like hardwares like resources, and then on top of that you have like hypervisors on VM, and on top of that you have kind of, and then that hypervisor part, Kubernetes is kind of replacing that. So if you see right now you have hardware resources on top of that of the public clouds, and in the middle OpenStack is kind of on parallel with Kubernetes. And in future, if the whole cloud part is going down, and Kubernetes is the abstraction part there, and then on top of that you have all the resources running. So Kubernetes is basically replacing your hypervisor part, I believe, that middle line, and it's basically becoming the de facto standard. But basically your VMware hypervisor is doing.
Yes.
Is that fine? Okay, let's give a prize to him. Yes, can you please? I want to request you to please join us on stage. We need to have a picture of you receiving the gift. Get the gift from here. Yeah, join us on stage. Eamon, I want to request you to please give this to him. Okay, let's have a big round of applause, everyone. Thank you so much. All right, Eamon, another question, one more question.
Okay. Before automating, I've said that there are two things that we should do before any automation. Huh? No, before automating, we should make sure that we have two things. We should simplify and, okay, security.
All right, you gave the answer anyway. But okay, ma'am, can I request you to please join us on stage quickly so that we can give you the second gift. Yeah. Let's have a big round of applause for this wonderful lady, everyone. She tried answering the first question as well. Okay, thank you, Eamon, for that wonderful session. Let's have a big round of applause for Eamon Al-Amri, who has joined us from Paris. And can I request Mr. Gopinath CH to please join us on stage and felicitate Eamon with a certificate and memento.
How are you?
Okay, can we have a please picture of both of them? Thank you so much, Eamon.